Welcome viewers to another episode of It Depends podcast. This is a live edition. We are recording this inside Heinz Convention Center in Boston, Massachusetts. We are here for IBM Think 2025. And we are in this amazing sports hall. I'm surrounded by a real-life Ferrari next to us. But more exciting than Ferrari is being reunited with my friend Dima. I have known Dima Spivak for many years. In fact, during the early days of Hadoop, when there was no great solution to ingest data into data lakes, that's when StreamSets came into existence, and Dima has been with them since the very beginning.
Pretty close.
Since
2016. Yep.
2016, okay, perfect. So Dima, I don't want to steal any more thunder. Please, if you don't mind, introduce yourself.
Sure, thanks Sanjeev. Yeah, StreamSets was acquired about 9 months ago, and at this point I'm the Vice President of StreamSets Development and Product Management here at IBM.
That is great. So as the name suggests, StreamSets, so the company started by doing streaming data integration. Why did the company's DNA was in streaming? Because at that time, and even today, batch integration is considered good enough sometimes, and it's very prevalent. So why streaming?
Yeah, it's a great question. I think that a lot of it really stems from the fact that a lot of what happened in the early days of Hadoop was really designed to solve problems that the more traditional approaches to data processing, data management just couldn't do. So a lot of the things Hadoop did, whether it came to the decoupling of the compute and the storage, the use of commodity, was really trying to be disruptive. And I think when it came to StreamSets, what we saw was that there are a lot of things on the market that do things in a very traditional way. A lot of batch processing, but what we started hearing from a lot of clients was that there are a lot of scenarios in which that's just not good enough. If you're trying to do fraud detection, if you're trying to do user personalization, if you're trying to do logistics, that's just not something you can do by processing something every day, even every hour, every few minutes. So StreamSets from the early days was really intended to reduce that latency and make it possible to kind of activate your data as soon as it's made available, rather than having to wait for your batch process to kick off.
What is the difference between stream ingestion and something like change data capture, for instance?
Yeah, in a lot of ways, they're very similar. In fact, streaming as a general term, I would say, is more of a pattern, right? So streaming is basically saying that as soon as data is made available, you begin to bring it into your systems.
Right.
CDC, for many cases, actually, I would say, is for a lot of enterprises, that's the starting point for streaming. So every enterprise will have a relational database. Many of them will discover, I have this data, but I actually have a use case where I want to get access to it as soon as it's written. And when they realize that they can enable a change data capture stream, that becomes kind of their first streaming source. And in many cases for StreamSets, that is the starting point for more robust kind of stream processing frameworks and a kind of more stream-centric view for a lot of enterprises.
Got it. I'm not sure if you have the actual statistics or approximation. What was the percentage of workloads that were streaming versus batch in 2016 when you started, and today? I'm just trying to get an idea.
Yep.
Is it static, or is streaming now more than 50% of the workloads? Or?
No. So definitely. So in 2016, the vast majority of workloads were definitely batch oriented, and a very small number were streaming oriented. Even to this day, batch is still the predominant style of data integration for most enterprises,
right?
Just because of its incumbency. But a number of analysts have found that the dynamic data movement side, the streaming data, the stream processing, is actually the fastest growing part of the market. So while you're going to still see that batch probably is upwards of 80% of use cases even today, the part that's growing in data integration definitely is that streaming area, as opposed to the more traditional approaches to ETL.
Why is streaming taking so long to become so predominant? It used to be, if I'm not mistaken, cost was a big issue. It was not worth. In fact, I remember the Lambda architecture, there was a speed layer and a batch layer, and it was kludgy. So, but today I see, we live in the era of generative AI. I see ChatGPT, for instance, has real-time video data feed, and so is cost still an issue? Is complexity an issue? Why is streaming not the de facto standard?
Yeah, I think it's a fantastic question. I think that one thing I tell a lot of our customers, even as somebody who runs an organization that focuses on streaming data integration, not every use case requires streaming data integration. So something I say a lot is that it will be more efficient. If you're populating a dashboard that somebody looks at once a week, you don't need to have that dashboard ingest running constantly.
Right.
But what we're really trying to do is find those customer use cases, those client problems that require you to process the data and where it's really sensitive to that latency. That's where streaming comes in. I think a lot of the challenge has also been that in the early days, just building a robust stream processing framework itself was difficult.
Yeah.
You saw it was only about 10 years ago that Kafka was created.
Correct.
It's only 10 years ago that the earlier systems like Storm got kind of replaced by the Kafkas. You now see Pulsar, you see Apache Flink for stream processing. So in many ways, the technology's there now, and now it's around the usability and kind of aligning the use case to the technology. And I think that's where StreamSets is really well positioned, is how do we make it easy for people, just as they can conceptualize building a batch data pipeline, how can we take that same kind of conceptual mindset and apply it to stream data processing? And that's really where we've had a lot of fun here at IBM.
Got it. So I want to pivot to IBM since we are at the show, although I do have to say that even if I'm looking at my dashboard once a week, I want the latest data. I don't want stale data.
Sure.
So what are you doing at IBM Think 25? What sessions do you have? What are you announcing that maybe you can spill the beans? By the time people watch this video, it'll be public knowledge?
Yeah, absolutely. So I think that within IBM, StreamSets has landed really well into the data platform side of our business.
Okay.
And the two biggest areas that data platform is investing in are around our approach to agents and agentic AI.
Yep.
So one of the big things you're going to hear a lot about this week is watsonx Orchestrate and the work that we're doing to really empower enterprises with agentic AI. The second big focus is definitely going to be on our data platform layer, especially watsonx.data. So you're going to see some announcements about how we're doing some really fascinating things with technology to bring together large language models with more traditional analytics, something that I think right now is a bit of a gap when it comes to using LLMs for kind of data for AI. And StreamSets is very much a part of that because we're part of a new offering that's being announced here at Think called watsonx.data integration. And watsonx.data integration is really about taking these incredible, powerful tools that IBM has had for a number of years. IBM has had data stage, data replication. A couple of years ago, it acquired a really great data observability company called Databand, and now StreamSets 9 months ago. And watsonx.data integration is really designed to say, users have all of these problems. Enterprises at scale suffer from all four of these problems in terms of needing to do batch ETL, real-time streaming, database synchronization, and observability. watsonx data integration is designed to bring all of those together into a single control plane, so you don't have to feel like you're managing 4 different products. It really is one product. And on top of that, watsonx.data integration is focused on bridging the usability gap that exists with a lot of legacy, or not even legacy, but maybe enterprise-focused ETL tools. And so whether you want to build a pipeline through drag and drop Canvas interfaces, whether you want to write a kind of Python-heavy data integration flow, or maybe something in between, watsonx.data integration is really designed to solve those use cases in one package.
So watsonx.data could be the streaming transport layer. On top of that, could I enable like an MCP protocol, a model context protocol, or even an agent-to-agent, like IBM has something called ACP. So is that the roadmap where you are heading to?
I think it's fair to say that our roadmap within the data platform organization here at IBM is really to bridge the gap between data for the purpose of data storage or analytics and data for the purpose of AI. So you'll see some of the talks here, but there's absolutely a lot of work happening to bridge these parts of our business, which previously we would talk about watsonx.ai, watsonx.governance, watsonx.data as kind of separate entities. You're definitely going to see that we as a team have started working much more closely to bring those together into an enterprise solution.
So if you remove that network latency and you have a common network substrate, then is it fair to say that watsonx.data, watsonx.governance, watsonx.ai with watsonx Orchestrate can then work in cohesion because the network thing is unified? Is that the idea? And
the goal of it is basically to say these will all be different tools that you're using for different parts of your AI experience. So when you think of watsonx.ai, it really is kind of your AI development studio. When you think of your governance, it's really around your model governance, how you govern the things you're implementing in production within your enterprise. watsonx.data, it started off as a more traditional data lakehouse, but now as we infuse it with the capabilities that people could then use to actually take that data and use it for generative AI use cases, I think that's where you're going to find that these three will start working really well together.
What sessions do you have here, if I may?
So myself, I'll be speaking tomorrow. We have a tech bite here where we're going to talk about StreamSets in particular. Again, StreamSets in the context that it forms a really critical part of watsonx.data integration, But in particular, I'm going to be talking about the value that real-time data integration has, because I think, again, even this many years in, and I know, as you said, it's people have been saying streaming is just 5 years away. Even now, when we talk about these use cases with customers, they you can see the wheels start turning, and they say, wow, that's actually a problem I have. I didn't realize that I could solve it in this kind of way. So we'll be talking about an example of it has a title, which is a little bit more enterprise friendly, but really the subtitle is what a Bangladesh bank heist can teach us about real-time data.
Oh my God, that is a name. That's a title.
That's my subtitle.
My God,
yep.
Wow. So, by the way, when you were saying, people say streaming is 5 years away, the thought that crossed my mind was, same thing happened for graph databases. Oh, graph databases are here, intuitive, and then 5 years go by and we're still talking about it. So tell us, what is something like exciting in this space? Like, what keeps you challenged, and what's this gap problem that you're trying to solve that hasn't been fulfilled?
Yeah, so I think one of them has definitely been around the fact that now that we're here at IBM, we have so many clients with so many problems, and it's been fascinating to just talk to them about the kind of issues that they're seeing, and it just gives us so much more exposure to how people are really using this technology. And before StreamSets was acquired, IBM really did have a gap in their data integration portfolio for these kind of real-time use cases. So one thing that's just been super exciting for me in the first 9 months here is talking to dozens and dozens of clients. That's been really exciting. What's been then exciting with all the smart people here at IBM, and you've met many of them, and they've been on this podcast, is just understanding how you can really eliminate a lot of the tool sprawl that I think has happened. I think if there's one thing that you've talked about, and I've definitely noticed, is that there's beginning to be a bit of a consolidation in the data space.
Yes.
And I think a lot of that is really driven by the fact that for a number of years, the modern data stack approach really led to fragmentation.
Correct.
And you would start seeing enterprises that may have, in the old days they were using one tool, now they're using 6, 7, 8, 9, 10 tools.
Right.
So what's been really exciting is recognizing how much great technology we have in one place and saying, what if we had a way of eliminating that tool sprawl? What if we actually had a way to say, your job should be solving business problems, not managing 6 different tools. And that's been a message we've taken to a number of IBM clients who've been very excited to see what we have in store here this week at Think.
Yep, I call it the chaos of fragmentation.
Yep.
Because there is a complexity, the maintenance, but it also then reflects in the trust that businesses have on data, which is not very high. It also reflects on the quality of the data because it's all fragmented, it's not complete. So that's exciting. I'm not sure, IBM being a public company, if you can talk about some customers, like how many customers are we talking about for StreamSets, and who are your premier customers, and what use cases do they have?
So I can't name numbers, unfortunately.
Yes,
that's something, as you probably know. But what I can tell you is, especially when it comes to industries, there's some that have really stood out for us. StreamSets in particular, because of how from the early days we were really architected to separate our control plane, where users are actually kind of building and managing their pipelines. We've always separated that from the data plane, where those pipelines are actually executed. Because of that, we've really found a foothold amongst regulated industries. So. I could say that there's some household names in terms of banks, in terms of insurance companies.
I see.
All of which you would probably hear and say, of course I know that company. Those are some of StreamSets' biggest flagship customers.
I see.
And the kind of use cases they see, I mean, one of my favorite examples is that we have a customer in the United Kingdom, large bank. And one of the use cases they had for StreamSets was that they were a bank that was really trying to address the challenger banks that were coming up. A lot of this competition that was trying to disrupt the banking industry, and they wanted to figure out how do we leverage all the data we have to improve our customer experience. So actually what they did was one of their 15 plus in production use cases that they have is that every time you swipe one of their credit cards at a point of sale, you get a text message in under 5 seconds. And those text messages are actually driven by StreamSets pipelines.
Oh, wow.
So we see these kind of use cases. It's not just about moving data, it's actually about building these better customer experiences. It means less customer churn, it means better customer experience, more trust, and ultimately growth for your business.
If I'm not mistaken, when I was first introduced, I think from get-go, you had support for unstructured data, files, right? You could read files.
Yep.
That was pretty prescient, if I may, because in 2016, no one was talking about unstructured data. How exactly do you read these unstructured, like what is the data flow, if I may, of reading a CSV, a PDF, an image?
Yeah, so the way StreamSets works behind the scenes is that as you said, we're very loose on schema. So we basically, what we do is when we read a file, for example, we allow a user to say, I'm reading a file, it's a CSV file.
Okay.
And so the user would then tell us, hey, here, you can assume that the first row of that file is a header that has certain details about fields. It's tab separated, comma separated, whatever it might be. StreamSets then interprets every line after that as a record. So it doesn't have to be relational. In fact, one of the things we definitely support is when you have this kind of semi-structured approach where maybe some of the rows have extra columns, some have fewer columns. But whether it's CSVs, whether it's JSON, whether it's XML, whether it's text files, another very common use case, by the way, that we see is around cybersecurity. A lot of users who want to ingest files, they're doing it because they want to do cybersecurity log ingest. And they want to not only move the files, but they actually want to be able to, in real time, act upon the things that they see in those files. So StreamSets has great support for Apache server access logs, all these sort of formats. And it's really because, as I said, behind the scenes, we're converting everything we see in these files into a common record format without requiring it to be very strict on schema. And then that's kind of handled more downstream.
Got it. And can you execute triggers and say, based on these conditions, like, what if there's like, you're reading logs and you find out for some reason there's like IP address, credit card numbers, sensitive data, what can I do to make sure it does not make it into my target?
Yeah, so you can do a number of things. You can actually mask the data in flight. So we have what we call processors, that a processor takes in a stream of data and does something to it and outputs it. At the same time, we have something we call executors. So it's kind of like triggers, but basically, based on something that happens in your flow, you can kick off an external process, you can trigger DDL operation on a table. You can really do all kinds of things with StreamSets. And what's really important about how we work is that we're not just a kind of A to B pipeline tool. We allow you to take one origin, process data, branch it out into 3 different locations, make changes on the fly. This is something StreamSets does really, really well.
How many connectors do you have?
So in total, we have we have this notion of stages. So we have about 200 stages. About 50 of those are origins, 50 are destinations, about 100 are processors. But one thing we often tell people is that we don't compete on the number of stages or connectors alone, because a lot of our connectors especially are general purpose. So we will have a single connector that can connect to vanilla Apache Kafka of any version. It can connect to Amazon MSK, it can connect to Confluent. Same for, we have origins and destinations for REST API, so what we call the HTTP or web client, which can connect to basically any compliant REST API, many types of authentication. So even if we might only have a single connector, that connector can actually connect to dozens of external systems.
Got it. We can geek on for a long time, but we're also getting a signal that we need to wrap it up.
Sure.
So I want to thank you, everyone. You guys have been amazing. Dima, it's taken us a very long time to get together, but thank you so much for coming to this episode. And viewers, I will see you next time. Thank you so much. Take care. Bye-bye.